last decade, global warming has become one of the most important environmental debates. Accurate estimates of lake volume are essential for informing the ecosystem's extent of regional biogeochemical models. These models are used to predict the future climate changes using various biological tests. Due to the lack of lake infrastructure, the use of lake volumes has become a very heavy field study. However, lake volumes are notoriously difficult to predict. My name is Catherine Levitan, and I currently attend the University of Kentucky studying animal science. This summer, I traveled to the University of Notre Dame to participate in the Data-Intensive Scientific Computing REU for 10 weeks. I worked on the coupled hydrologic and biochemical modeling of lake regions under Dr. Stuart Jones and graduate student Jacob Zwart. Land surface temperature is a very important climate variable when representing surface air temperature and energy. It has been found that its boundaries are defined by the difference in skin and surface air temperature. Using satellites to obtain land surface data, thermal emissions at various wavelengths must be examined. The objective of our study was to improve estimates of lake volume using publicly available satellite-derived data. The Earth Observing System Terra and Aqua satellite was used to source the moderate resolution imaging spectrometer to obtain the land surface temperatures. The data was extracted from a 50 kilometer by 50 kilometer region in upper Wisconsin where 163 lakes reside. A major problem with land surface derived data is the inclusion of the entire land region. Geospatial analysis was used to extract lake data only. Using Model Builder, a visual programming language for the construction of geoprocessing workflows, the desired data was extracted. Using R, I reformatted the files to be organized by lake name. Each lake file contained a column for year, time of day, which was either day or night, day of year, and temperature values designated as Kelvin. By plotting temperature against day of year, a best fit line could be used. This line was quadratic. The variables A and B were used as 2 of the 5 parameters for the model test. A package in R, AICC, was used to predict as many possible models using 5 different parameters. These parameters included A and B, given from the quadratic line, lake area, change in temperature, and maximum temperature. A test model was created using the 5 parameters in addition to known volumes and areas for several lakes. Observed values for volumes were calculated using the table. Plotting the log of the observed volumes against the log of the actual volumes allowed us to examine our test model. The model we generated provided a more accurate and efficient way to predict lake volumes, although a lot of research can still be done to obtain even more precise lake volumes and create a universal test model. By developing a universal model of lake volumes, we will be one step closer in understanding how climate change is affected by lake volumes.